Hello everyone. Time doesn't stop. Then why we should stop? Keep learning. Once again, welcome to computer science class. In last class, we have seen some of the conversions. Mainly, how to convert a number from decimal to binary. Today we shall look into some more examples. Moving further, next number or our next conversion will be decimal fraction to binary. In the last class, we have seen whenever a decimal number is given, for example, suppose a number is given like 23 to the base 10 is how much to the base 2. That means we are going to convert the number from decimal to binary. What we have done? We have taken the number 23 and we have divided by 2. We had written the fraction, we have written the quotient and the remainder. Again we have divided the quotient with respect to 2. Once again note the quotient and the remainder. Keep on dividing the quotient till the quotient becomes 0. Then from bottom up, whatever reminders we got, write those reminders in this order. Okay, today we shall see one more concept, that is decimal fraction to binary. So what is the fraction? Whenever we write a number 2, it's an integer, it's whole number, right? It's okay. 23 again whole number, it's an integer. Suppose we have something like 2, 5, 6. This is called as fraction. So we shall take one example. 0.3125 to the base 10 is how much to the base 2? When it was an integer, we have divided that with respect to 2 because to this particular base we want to convert. Only thing that we have to note here is that it's having only fraction, it doesn't have any integer. Suppose we have both, how to convert that later we shall see. In this case, what we need to do, we shall write 0.3125 into 2. Double the number, just add the same number twice. So what happens in that case? Before that, here we will write something like this, carry and the product. The number that is given to us is 0.3125. So 0.3125 into 2, double the number. What we will get? 6250, right? Multiplying by 2. So 0.6250. Even if you don't write this 0, it's okay. Whenever we are having, see, when we have a point, if you have a 0 towards, if it is towards this right side, even if you don't write, the value doesn't change. If you say number, let me write here just for your information. When we write an integer 5, if you add a 0 to the left side, the value doesn't change. But if it's a fraction, it's an integer, I will write a fraction here, 2, 5 is 0. So that means after point, even if you don't write the 0, the value doesn't change. It will be the same. Okay. Here also the same thing. So in this case, when we multiply the number with the 2, we will get a product. Just note this. So here, whatever we get, either we will get 0 or 1. No other value is possible because we are going to write with respect to 2, we are going to multiply. Now, since it is 0.6250, write this 0 and a carry. Once again I will write here 0.3125 after, or 0.3125. After multiplying by 2, this is 0.6250. So we have 0 here, that's why I write 0, and write this one 0.6250, or you can leave this 0 here. Next step, once again you have to multiply by 2. What we will get? 0, double this, that is add twice, 0, 5, 5, 10, 1 in hand, 4, 5, 6, 6, 12, 1. There is a carry here, 1.2500. We can write it as 1.25 also, no problem. Now, in this case, since it is 1.25, we can't write here 1.25. We will split it. How we are going to split? Write that one here, and in this here, whatever is pending, you write here 0.2500. After this, what to do? Next step will be, already we have written this 1 here. We are not going to multiply 2 to this one. We are going to multiply 2.2500 into 2. Once again, already we have taken that 1 here. So while multiplying with respect to 2 for the next step, don't take that 1. Already we have written that 1 here. Only for the fractional part we have to multiply. This is just a way of writing it. Okay, multiply this. How much it will be? It will be 0.25 twice. That will be 5000. Do we have 1 here or 0? We have 0. So what we need to write in this step? We have to write 0 because there is no carry. Here it is the same, 0.5000 or 0.5. Next step, once again multiply by 2. Now how much you will get? Twice. So it will be 0, 0, 0, 5 plus 5, it's 10. 10 in the sense, it will be 0 with the carry 1. So how much we got? 1.0000. So how much we need to write here? How much we have to write here? It's 1, and what's this value? It is 0.0000. Once we get 0 somewhere like this, we have to stop. And we don't want this part now. Once we got a 0, we have to stop here. But what to write? In the previous case, when we were converting it to decimal to binary, after writing the quotient and remainder, once we got the quotient as 0, we had written the values from bottom to top, right? Here also we have to write something, but in a reverse order. In this case, it will be like this, top down. There it was, bottom up. That's why, since it is a fraction, we have to write dot, that is a binary point. What's the first value? This will be MSB and this will be LSB in the fraction part. So it will be 0, 1, 0, 1 to the base. So what we can write? 0.3125 to the base 10 is equal to 0.0101 to the base 2. Hope this is understood. Be careful while multiplying. If you get a carry, for example, in this case, in the step 2, in the first step, when we multiply 0.3125 by 2, we got 0.6250. Since we don't have any carry, we had written 0 here. But when we multiplied with respect to 2 once again, it was 1.2500. So when it is 1.2500, we will write 1 here and 0.2500 here. While multiplying once again, we are not going to multiply with respect to 1.25, we will multiply only to the fraction. So whatever fractions are here, for those fractions we have to multiply by 2 and get the answer in the next step. So the answer in the next step may be having 1 point something or 0 point something. If it is 0 point something, write it as it is. If it is 1 point something, write 1 here and the remaining fraction to the other side and multiply to that fraction to the next step. Next one, binary to decimal. Binary to decimal. Let us take any number. For example, 1, 0, 1, 1. How to convert this to decimal? When we were converting from decimal to binary, what we have done? We have divided the number with respect to 2. Write the quotient and remainder and continue the process. In this case, it is binary to decimal, that means 1011 to the base 2 is binary, is how much to the base 10? Easy. We know the weights, the positional values we know. This is, so let me write it over here once, 1011. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 0 is how much? It's 1. Anything to the power 0 is 1. It may be 100 to the power 0 or 1000 to the power 0. It will be, the answer will be 1. 2 to the power 1 is 2. 2 to the power 2, 4, 2 to the power 3, 8. So how to convert? We know the positional values. So we shall write 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. 1 into 2 to the power 3 because 2 to the power 3. 0, 1, 2, 3. Plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Write those values. 1 into 2 to the power 3 is 8. Plus 0, anyhow when we are going to multiply to a 0, the answer will be 0, no need of writing this one. Plus 1 into 2 to the power 1 is 2 plus 1 into 2 to the power 0 is 1. Be careful, don't write it as 0. Usually we will go wrong here. Even though it's easy exercise, but still we will make mistakes because of this one. This will be 1 into 8, 0. 1 into 2 is 2, 1 into 1 is 1. So it is 8 plus 2, so that is 10 plus 1, 11. Hope this is understood. Easy exercise. One more example we shall take. One, 0, 1, 1, 0.101. Be careful in this case. to the base 2 is how much to the base 10. In this case, what we have? We have a binary point. So whenever we have a binary point, which is 2 to the power 0, is this one or this one? Let's write here also once. See, this is a binary point. So 2 to the power 0 will be this one, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. This will be, positional value will be 2 to the power minus 1. Remember, this is 2 to the power 0. A binary point, 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3. While writing the next step, what we will do? 1 into 2 to the power, how much? 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Till here it's okay. But what about this value? 0.101, binary point. That's why plus 1 into 2 to the power minus 1, that is for this one, plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. For our information, what is the meaning of 2 to the power minus 1? Let us continue, but before that let us just go through this once. 2 to the power minus 1. Its meaning is that 1 by 2 to the power 1, that's equal to 1 by 2. Or what is the meaning of 2 to the power minus 2? This will be 1 by 2 to the power 2, or 1 by 2 to the 2 into 2s are 4, 1 by 4. What is the answer for this? 1 by 2 is 0.5, right? Half. Minus 2, 1 by 4 is half of this. Half of this half. Half of 0.5 will be 0.25. Suppose we have 2 to the power minus 3. Suppose we have 2 to the power minus 3. Let me write it over here, 2 to the power minus 3. What is the answer? 1 by 2 to the power 3, that is 1 by 2 into 2 into 2, 3 times, that's 8. What is that? 1 by 8 is half of this. Half of 0.25 will be 0.125. These values we need to remember because that will be used for the calculation purpose. Somewhere you can write down if you want. 2 to the power minus 1 is half, 0.5. 2 to the power minus 2 is 1 by 4, which is equal to 0.25. 2 to the power minus 3 is 1 by 2 to the power 3, which is equal to 1 by 8, which is equal to 0.125. Now let us simplify this. 1 into 2 to the power 4. 2 to the power 4 is how much? 1, 2, 4, 8, 16, 32. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. In this case, what we have? 2 to the power 4. 2 to the power 4 is 16. Multiply 2 4 times. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 2 to the power 4 is 16. So 1 into 16 plus 1 into 2 to the power 3, that's 8, plus 0 plus 1 into 2 plus 1 into 2 to the power 0. Once again, 2 to the power 0 is 1, plus 1 into 2 to the power minus 1 is how much? 0.5 plus 0. We need not write this one because this is 0, plus 1 into 2 to the power minus 3, that is 0.125. Now add it up. 16 plus 8 plus 2 plus 1 plus 0.5 plus 0.125. This is fraction. Be careful. If you want, somewhere you write down like this: 16, 8, 2, 1. Below that, it's 0.5. Don't write 5 here. It is 0.5 and 0.125. Directly you can add it here, but if you have any confusions, for that purpose I have written it here. What happens in this case? 5 here, 2 here, 5, 1, 6, 1, 3, 10, 16, 17, 1 head, 27. Is it right? Yeah, right. That is 27.625. Just cross verify this once. Hope it's understood. No problem with this one. The problem comes in understanding this side, that is the right side of the fraction. Only thing we need to remember is 2 to the power minus 1 is half, that is 0.5. 2 to the power minus 2 is half of that, that is 0.25. 2 to the power minus 3 is half of that is 125. Conversion of decimal fraction to binary we have seen. That type of problem comes only in decimal to binary. Fraction from any other number system to decimal we don't have. Only for binary and from decimal to binary we have. Moving further, we shall have decimal to binary we have seen. The next one is octal. In case of conversion from decimal to binary, I would like to repeat, decimal to binary, what we have done? We have divided the given number by 2 because decimal is the base 10. What we want to convert is to binary, so divide by 2. In this case, it is decimal to octal. If it is binary, divide by 2. If it is decimal to octal, divide by how much? It's by 8. So whenever a number is given which has to be converted from decimal to octal, divide by 8. Then what next? The procedure will be the same as we have done it for the binary. Note down the quotient and remainder. Keep on dividing the quotient till the quotient becomes 0. Then from bottom to top, whatever remainders you got, write down that. That will be octal number which we have converted from decimal to octal. One example we shall see. 459 to the base 10 is how much to the base 8? What we need to do? 459 divided by 8. So for your understanding, you can write like this: 45 you take, divide by 8. Of course 9 also we can write. It's for our understanding, that's all. Directly we can write the values here if you are familiar with the numbers. How many times? If you are going to divide If it is 5 times, it will be 40. Right? So how much is pending now? 45 minus 40, that will be 5. It's not 45, it's 459. Write that 9 here. Then 59, 8, 5s are 40, 6 are 48, 7s are 56. So 7, it is 56. Right? So here in this case it is 3. That's why what we can write here is 57. What the remainder? A remainder is 3. Hope this is understood. Whatever number is given to us, divide that number with respect to 8, note down the quotient and the remainder. We should know the multiplication table. Of course, everyone is familiar with the multiplication table of 8. 45, 5 times, that is 40, 5 is remaining. So 5 is remaining, 5 and 9, 59. In 59, we can get 56. 56 is 7 times. So 56, 59 minus 56 is 3. That is the remainder. Write that. Once again, divide the number with 8. How much we will get? Again it is 7, because what we have is 57 divided by 8. 8 5s are 40, 8 6s are 48, 8 7s are 56. So 7, so 56, remainder is 1. So write that 1 here. Whether the quotient is 0? No. So divide it once again. 8. Can we divide 7 by 8? No, it's not possible. So what is the quotient? Quotient is 0. And what is the remainder? Remainder is 7. So what we have to do now? The same procedure that we have done with respect to the binary, decimal to binary. Bottom up. So what is that? 7, 1 and 3 to the base 8. So what we can write? 459 is equal to 713 to the base 8. Just remember, to any number system, if you are going to convert from decimal to any other number system, to which particular number system we want to convert, with respect to that base, divide the given number which is given in decimal. Here it is octal, so divide by 8. Note down the quotient and the remainder. Keep on dividing the quotient till the quotient becomes 0. Once the quotient is 0, write down the remainders from the bottom to top in the reverse order. So which is the MSB here? The last remainder will be MSB and the first remainder will be LSB. That's why 7, 1, 3. Three to the base 10 is how much to the base 8? Try this. What we should do? 253 divided by 8. 8 3s are 24. 1 in hand. That is 1 is the difference. 3. 8 1s are 8. 13 minus 8 is 5. That means when we write 253 divided by 8, we got the quotient as 31 and the remainder is 5. Hope that's right. 8 3s are 24. 25 minus 24 is 1. This 3 get it here, 13 divided by 8. 8 1s are 8. 13 minus 8 is 5. So 5. Once again divide 31 by 8. How many times? 8 1s are 8, 8 2s are 16, 8 3s are 24, 8 4s are 32. But 32 is not there. So 8 3s are 24. So when we write, for example, 31 divided by 8, 31 divided by 8, 8 3s are 24. This will be 31 minus 24 will be 7. So what we should write? 3 quotient 3 times, that's 24. Remaining is 7. Once again divide by 8. We can't divide 3, so 3 becomes the remainder, that's why 0 and 3. Once again do the same. This is MSB and this is LSB. So this will be 3 7 5 to the base 8. So what we can write? This workout is not compulsory, just to make you to understand. So 253 to the base 10 is 375 to the base 8. Moving further, decimal to octal we have seen. Now, next one will be octal to decimal. Octal to decimal. Two, 3, 4 to the base 8 is how much to the base 10? Just recall, from binary to decimal what we have done. We have taken those digits and we have multiplied with respect to the positional values. There it was 2 to the power 0, 2 to the power 1, 2 to the power 2, etc. If you go to the other side of the fraction, it will be 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, etc., etc. But since it is octal, we can't have 2 to the power, it's a to the power something. That's why if it is given like this, what we can write? We can write 2 into a to the power 0, 1, 2 plus 3 into a to the power 1 plus 4 into a to the power 0. That is 2 into 8 8s are 64 plus 3 into a to the power 1 is 8 plus 4 into a to the power 0 is how much? Once again it is 1. Multiply and write 64 plus 64, 128. 8 3s are 24 plus 4, add it up, 128, 24 plus 4, 16, 1 in hand, 3, 4, 5, 156. It's easy when we have the integer values. Suppose we have the fractions, just like we had in binary. then again it becomes a to the power minus 1, a to the power minus 2, etc. to the other side of the fraction. Suppose we have 123.56. This is, say, 123.56 to the base 8 is how much to the base 10? Here it is octal point. It is octal point. That's why 2 to the power, it's not 2 to the power, it's a to the power. A to the power 0 is this one, a to the power 1, a to the power 2, a to the power minus 1, a to the power minus 2. That's why it becomes 1 into a to the power 0, 1, 2 plus 2 into a to the power 1 plus 3 into a to the power 0 plus 5 into a to the power minus 1 plus 6 into a to the power minus 2, which could be written as 1 into 8 square, 8 into 8, 64, plus 2 into 8 plus 3 into 1 plus 5 into 1 by 8 plus 6 into a to the 8. Why we have written 8? A to the power minus 1 is 1 by a to the power 8, 1 by a to the power 1. A to the power 1 is 8 itself. 6 into, actually a to the power minus 2 could be written as 1 by a to the power 2. 1 by a to the power 2 is 1 by 64. So 1 by 64. It will be very, very small value because 1 divided by 64. 1 by 4 itself 0.25. 1 by 4. 0.25 is half, is 1 by 8. It will be a very small value. So it will be 64 plus 8, 16 plus 3 plus 5 into 1 by 8. Just calculate that. 1 by 8 is somewhere around 0.125. 0.125 plus 6 into, it will be a very, very small value, 0.0 something, 0.015. 0.015. So again 64 plus 16 plus 3 plus 5 into 0.125, it is 0.625. 0.625. 6 into 0.015 will be 0.09. 0.09. It doesn't make much difference in the answer because 0 point something here. Now add it up. When we add this number, be careful while adding because fractional part should be added with the fractional part only. That's why 64, 16, 3, 0.625, 0.09, 5, 11, 7, 83, cross verify, 5, 7, 16, 64, 16, 3. .715. 83.715. So till now what we have seen, the conversion between the decimal and binary, conversion between decimal fraction to binary, then decimal to octal we have seen, octal to decimal we have seen. In this case we also had the fractional part, so it doesn't make much difference, only these things, these values we need to know, that is the fractional values. You can take the help of simple calculators for the time being. In the next class we shall see the conversion between the decimal to hexadecimal, hexadecimal to decimal, then some conversions between octal to binary, octal to hexadecimal, etc., etc. Thank you.